let's talk about SAST, or Static Application Security Testing. In our hyper-connected world, one single vulnerability in the code can lead to massive data breaches. We see it in the news all the time. It can cause huge financial losses and completely shatter a company's reputation. Security just isn't a feature you can tack on at the end anymore. It has to be woven right into the software's DNA, right from the very beginning. So, the big question is, how do you actually weave that security in, right from the very first line of code? Well, the answer lies in a really proactive approach called static application security testing. You can think of it like an essential shield, one that protects your software from the inside out. And the core idea here is actually pretty fascinating. The best way to think about it is like a spell checker for your code. But instead of looking for grammar mistakes, it's hunting for security flaws. See, SAST analyzes the application's actual blueprint, the source code itself, to find these potential problems before the program is ever even run. It doesn't need to see the software in action to find a weakness, which is pretty cool.
So how does it work? Well, the process is brilliantly simple, really. First, the tool just scans the code. Then, it uses this huge knowledge base to identify potential security vulnerabilities. Scary-sounding things like SQL injection, or attackers can sneak malicious commands into a database, or buffer overflows, which can let them take control of a program. And finally, and this is the most crucial step, it gives immediate, actionable feedback right back to the developers.
And that idea of immediate feedback, that is absolutely central to a truly game-changing concept in software development called shifting left. And all that really means is moving security testing to the earliest possible point in the process. It's about making security a proactive habit, not some last-minute reactive scramble. And wow, the difference is just stark. The old way, the traditional approach, meant you found flaws late in the game. And by then, they're incredibly expensive and super complex to fix, creating huge business risks. But with SAST, you find them early, they're way simpler and cheaper to fix, the risk is minimal, and this is key, the whole process gets integrated right into the developer's normal, everyday workflow. Just look at this cost difference. Seriously, fixing a bug that you find during development, okay, that's one thing. But fixing that exact same bug once the software is live in production, whoa. We are not talking about a small increase here. It can be over 60 times more expensive. And that's not even counting the reputational damage it might have already caused. But here's the thing. SAST is so much more than just a bug-finding tool. It's really like having an automated code reviewer that helps developers build better coding habits. Think about it. By repeatedly flagging a certain type of vulnerability, it's actually teaching the developer what to look for. It becomes this continuous learning tool. So that feedback loop doesn't just fix the code right now, it prevents future mistakes, which reduces long-term technical debt and just creates stronger, more maintainable software. Okay, so how does this proactive approach actually work in the real world? In today's nonstop cycle of development and deployment, let's take a look at SAST's role inside a modern DevSecOps pipeline where speed and security can't be a trade-off. They absolutely have to be partners. Okay, so picture this. A developer writes some new code and commits it to the project. What happens next? Instantly, an automated SAST scan just kicks off in the background. And within minutes, often before the developer has even had a chance to switch to another task, the results are delivered right back into their programming environment. It's amazing. Security just becomes the seamless, natural part of their daily routine. And in a lot of high-stakes industries, this isn't just a nice-to-have or a best practice, it's completely non-negotiable. We're talking about protecting our financial data with rules like PCI DSS, or safeguarding our private patient records under HIPAA. It even extends to ensuring the physical safety of drivers with all the software that's in our cars today. For these sectors, SAST is an absolutely foundational tool for meeting these critical compliance mandates. But the story doesn't end there, not at all. SAST itself is evolving. It's becoming more powerful, more intelligent, and that's largely thanks to the rise of artificial intelligence. And honestly, this is where things get really, really exciting. So the traditional SAST tools, they were very rule-based, and that often led to this flood of false positives. Just a ton of noise. It's like a smoke detector that goes off every time you make toast. But modern, AI-powered tools, they're totally different. By training on massive amounts of code, they actually learn to understand an application's context and even the developer's intent. This lets them see the bigger picture, so they can pinpoint really complex flaws, like broken authorization logic, and then automatically prioritize the risks that truly matter. And this AI-driven approach is, well, it's truly transformative.
It dramatically cuts down on that alert fatigue that can just totally overwhelm security teams simply by filtering out all that noise. It automatically prioritizes the vulnerabilities that pose the biggest threat, so developers know exactly where to focus their efforts. And it even goes a step further by suggesting fixes, or in some cases, even generating ready-to-use code patches. That just radically shrinks the time it takes to go from detection to fix. So, when you put all of this together, what do you get? You start to see that SAST isn't just about a piece of technology. It's actually a strategic enabler for something much bigger, and I think much more important. The ultimate goal here is to build a true culture of security. What does that mean? It's about creating shared responsibility. It's a world where development, security, and operations teams all collaborate to build software that isn't just functional, but is fundamentally resilient, software that's worthy of our trust. And that really leaves us with a final, crucial question to think about. In a world that quite literally runs on code, we all have to ask ourselves, is the software we're building and the software we use every single day built on a solid foundation of trust?